Welcome to Sessions Online Mass Tutoring. We are looking at IGCSE, final exam for Cambridge students. Paper 0606, May, June 2025. Paper 22. Question 1. How the inequality does. Know that if the absolute value is greater than 3 or any value, so the solution is that function greater than or equal to the k or the 3, and then that function less or equal to the negative of that. If it is also less, then it means that function less, then the other one will be the greater. That's how it works. So with this, we can look at it from 2 points. Where we say that the 5x plus 2 should be greater or equal to 3. So solving this, you can see 5x is 3 minus 2, then 5x is 1. So x is 1 on 5. Then we can say that our 5x plus 2 is the opposite, greater, less or equal to the negative of that is 3. So our 5x is neg 3, neg 2. Our 5x is neg 5 on 5 on 5. X is less or equal to negative 1. So bringing this together, negative 1 is greater or equal to x, and that x is greater or equal to 1 out of 5. That ends question number 1. Now, question number 2. A particle P moves in a straight line such that its displacement S is that. On the axis, get the displacement time graph of P, stating the intercept with the axis. So let's first take the intercept. At the S-intercept, after S-intercept, T0, after S-intercept, T0. So if T0, we have S to be 0 minus 4 squared, that's neg 4 squared, and then 0 minus 1 is neg 1. So that's going to be 16 times neg 1, that's neg 16. So in that case, we are going to have the T0 and then S is neg 16. At T-intercept, S is 0. So we are going to have T minus 4 squared, T plus 1 to be equal to 0. So in that case, T plus 1 equal to 0. T is negative 1. T minus 4 squared equal to 0. Yes, T minus 4 equals 0. T is 4. So we are going to have negative 1, 0. And then you're also going to have 4, 0. So if you are going to draw a graph, we have 0 next 16. So you can indicate our next 16 somewhere here. Then we have next 1. Oh, sorry, T minus 1. So with T minus 1, then T is 1. So 1, 0. We can have our 1 here. We can have our 4 here. So if you are drawing, 4, 0 is twice because of the square there. So what this means is that we are going to have something like this at 4, 0. You can start our graph from this. And then we get to 4, 0 like this. Then we go upwards like this. Don't forget that time cannot be negative. So our graph should start from next 16. And then go to 1, come to 4, and then go upwards. That will be our graph. Then we are looking at the next aspect of the question, where we have to find the velocity v of the P. The velocity v is always change in acceleration over change with respect to change in time, which is the s dt. So if you are doing this, differentiate one, keep the other. So I'll keep t minus 1, differentiate that. I'm going to have 2 down, t minus 4, exponent 1 dot the inner one as 1, plus I'm going to keep t minus 4 squared, and I'll differentiate t minus 1, that will be 1. So if I watch this 2, t minus 4 is common, I factor it out. So I have 2 out t minus 1 plus t minus 4 in the bracket here. So I'm continuing up there. So I have t minus 4 out. If I expand, I'm going to have 2t minus 2 plus t minus 4. If I work on the other bracket, I'm going to have 2t plus 3 is 3t. Next 2, next 4 is next 6. In that sense, 3 is also common. So that's t minus 4, then t minus 2. And this becomes the velocity in a factorized form. You have to sketch the velocity graph. So if you are going to sketch that, don't forget our velocity is 3t minus 6, then t minus 4. If you are sketching this at t0, you are going to have next 6 times next 4, and that is 24. So that point is 0, 24. And at v is there, are going to have 3t minus 6 to be equal to 0. And that will mean 3t is equal to 6. So t is 2. So that's 2, 0. We'll have t minus 4 equal to 0. That also be 4, 0. So in that case, I'm going to plot this. So 0, 24 up there. Let's indicate that 24 there. Then we'll have 2. Then we can have our 4 here. 0, 24. Don't forget the time cannot be negative. Right to this. You move up like this. And that is going to be our graph inside this. So now the D, we are going to find an expression for acceleration. We are finding an expression for acceleration. So that's differentiating the velocity with respect to time. That's acceleration. So acceleration is dv dt. So if I have v as 3t minus 6 and t minus 4, I keep 1. I can keep 3t minus 6. I differentiate that, I have 1. I keep t minus 4. I differentiate this, I have 3. So I have 3t minus 6 times 1 is 3t minus 6. And I have 3 times t, 3t minus 12. 3t, 3t, 6t. Next 6, next 12 is next 18. And that is my acceleration in meters per second squared. Now, we move on to the E part, where I'm supposed to sketch the graph of the acceleration, stating clearly the intercept. So 60 minus 18 at a equals 0, look for that. 60 should be 18. So t is 18 over 6, that's 3, that's 3, 0. At t equals 0, a is neck 18, so that's going to be 0 neck 18. If I look for this 3, 0, so 3, 0 can be here. Then we can look at 0, 18, somewhere here. So I draw this like this. I connect this right to the 0, 18. And that gives me the graph of the acceleration in time. Now I'm looking at question number 3. I'm solving f of gx equal to 1. F of gx is equal to 1. So looking at f of gx, so I'm going to put gx into fx. So f of gx is going to be 3 x is gx, that's root x plus 2, all out of x, which is still root x plus 2 plus 4. And that should be equal to 1. So if I multiply through by the denominator, I'm going to have 3 root x plus 2 is equal to 1 times that is still the same thing, root x plus 2 plus 4. I group like this. I'm going to have 3 root x plus 2 minus root x plus 2 equal to 4. So these are the same. So I'm going to just subtract the coefficient. 3 minus 1 is 2. Root x plus 2 is equal to 4. Divide through by 2. So root x plus 2 should be equal to 2. Square both sides. This square takes up the square root. You can say x plus 2 is equal to 2 squared 4. So x becomes 4 minus 2. So x is 2. Done with question number 3 for 4 marks. Go to question number 4. Given that we have our y to be 4 sine 2x cos x, that we find the y dx. We find the y dx when x is pi on 6. So don't forget, this is going to be function times the function. So you can use the product rule. So in that case, we can just let u be equal to 4 sine 2x. Then let v be equal to cos 2x. Okay. So now, what is the differential of u? That's u prime. It's going to be differentiate sine 2x. That will be 2. Already have 4 here. Times cos 2x. Right? So differentiate sine 2x, that's cos 2x. And differentiate 2x, that's the 2 I have here. So that's u prime being 8 cos 2x. Then v prime, differentiate cos 2x. That will be negative sine 2x. Then differentiate 2x, that will be 2. So v prime will also be negative 2 sine 2x. So how do you differentiate? Dy dx should be u. Keep the u, that is 4 sine 2x times differentiate the v, which is negative 2 sine 2x, plus keep the v, which is cos 2x, times differentiate the u, which is 8 cos 2x. So dy dx should now be negative 8 sine squared 2x plus 8 cos squared 2x. Now we having this, don't forget, we can factor out, or we can leave it this way, negative 8. Now what is sine 2x? We substitute. So that's sine squared 2 times pi on 6 as my x plus 8 cos squared 2 times pi on 6 as my x. So 2 times pi on 6 is pi on 3. I'm going to get negative 8 sine squared pi on 3 plus 8 cos squared still pi on 3 because that's the 2 times that. So what's sine pi on 3? So sine pi on 3 is root. Use your calculator, that's root 3 out of 2. And that is squared. What's cos pi on 3? That is also half. So that's half squared. So that's negative 8 times 3 out of 4. Then we have plus 8 times 1 out of 4. So this the negative 8 times 8, 4 here, 1, 4 there, 2, that's next 6. 4 here, 1, 4 here, 2, that's plus 2. So our answer is negative 4 for the 4A. Now 4B, we are going to look at the curve is the hazard equation. The normal to the curve is at point x equals pi on 6 means the x axis at point P. So let's find the normal to the curve at point x is pi on 6. If x is pi on 6, what will be y? So y should be 4 times sine 2 pi on 6 cos 2 pi on 6. Don't forget, this is going to be pi on 2, 4 sine pi on 3 cos pi on 3. What sine pi on 3? We had do 3 out of 2. What's cos pi on 3? We had half. So this is 4. Taking off this 4, our answer is root 3. So it means the point we are looking for is at x pi on 6 and the y is root 3. Now the gradient of this particular function at pi on 6, we had negative 4. Don't forget that's the gradient of the normal of the tangent. So the normal's gradient is the negative reciprocal of that, and that's 1 out of 4. So the gradient is 1 out of 4. So we are going to find the equation of the normal. Y minus what's y1, which 3 equals 1 out of 4. That's the gradient. X minus what's x1, pi on 6. You don't forget that this equation can be y equals root 3 and root 3 there plus 1/4 x minus pi on 6. You can leave it at this form. But then we are looking at the point where this equation meets the x-axis. So if it meets the x-axis, don't forget at that point y is 0. So y is 0, root 3 plus, can expand now, 1/4 x minus pi on 24. Moving a step further, multiply 3 by 4, that's still 0. And this is 4 root 3. This is x. This is pi on 6. So x becomes pi on 6. Okay, that's crossing the equal sign. Then 4 root 3 will now become minus 4 root 3. Then that is x. So x is pi on 6 minus 4 root 3. And the y coordinate is 0. So our final answer will be pi on 6 minus 4 root 3, comma 0. That is the coordinate of P. Question number 5. A 4-digit number is to be formed. Look at the digits 0, 2, 4, 5, 6, and 8. The 4-digit number must not start with 0. So 1, 2, 3, 4. The numbers are 6. If it must not start with 0, it means 5 numbers can be here. Then, how many numbers are left? I select one out of, then that can be 5 numbers. By choosing one, there should be 5 numbers to choose from for the second option because we are to use at most ones. 4 numbers will be left for this. 3 will be left for this. So now I'm going to find it as 5 times 5 times 4 times 3. 5, 4 is 20. 5, 3 is 15. 20 times 15 is 300. Done with the A part, the I part for 1 mark. Find how many even 4-digit numbers can be formed. So for even 4-digit numbers, don't forget that we have 2 ways of doing that. 1, 2, 3, 4. The last digit can be 0. In that situation, it means that we have 1 option here. So we need just these 3 to be able to solve. The last digit is 0. We can choose from the remaining 5 numbers here. Then we have chosen 2 numbers. 2 minus the 6, we have now 4 numbers to choose from. Then we have 3 to choose from. So 5 times 4 times 3 should also give me 60. That's the first option. Now for it to also be even, the last numbers can either be 2, 4, 6, or 8. And that's 4 options there that we can choose from. Now the first number cannot be 0. If it can't be 0, it means that we have 1 number we cannot choose 0, and we have one of these 2, 4, 6, 8 we cannot choose from. That's 2 options gone. And don't forget, it can also be 5. Sorry, that's 2 options except 0 and then the last number. And that's going to also be 4 options here because there are 6 numbers. You can choose 0 here, so you have 4 numbers to choose from again. Then we can choose 3 numbers here. So that's going to be 4 times 4, 16, times 3, 48, times 4, 192, plus my 60, and that's going to be 252 to choose from. The third one, we are looking at how many 4-digit numbers that are divisible by 5 can be formed. So divisible by 5, last digits can be 0 or 5. 1, 2, 3. This is 0, so that's 1 option for the 0. So we have 5 numbers to choose from. 0 is gone, meaning 4, 3. So 5, 4, 20 times 3 is 60. The next option, we can choose 5, which is 1. So choosing 5, we cannot choose 0. So left with 4 numbers here to be choosing from. Choosing 1 and 1 at the end, so that's 4 more again here. And then 3. 4, 3 is 12. 12 times 4 is 48. So you have 60 plus 48, and that is 108. And that ends it for that particular question also. So we take the next question, that's the B. N plus 1 times. So we look at the factorial here. Combination using factorial. So n plus 1 combination 12 is going to be n plus 1 factorial out of n minus r factorial, that's minus 12 factorial times 12 factorial. And that should be equal to 33 n minus 10. Then we can have n combination 10, that's n factorial out of n minus 10 factorial times 10 factorial. Put it all together, I'm going to have n plus 1 factorial all out of n minus 11 factorial 12 factorial, and that should be equal to 33 n minus 10 n factorial all out of n minus 10 factorial 10 factorial. So note that if I cross multiply, so it means that the top we can look at it as n plus 1 factorial n minus 10 factorial 10 factorial, and that should be equal to n minus 11 factorial 12 factorial. I'm cross multiplying 33 n minus 10 then n factorial. If I have this and I'm proceeding, I can take off some of these things. If I have n minus 10 factorial here, n minus 11 factorial can be no n plus 1 factorial can be n plus 1 n plus 1, then I reduce it by 1 n factorial. Then I have n minus 10 factorial can also be n minus 10 times, so that will be n minus 11 factorial. Then I have 10 factorial there. So watch carefully. This n minus 11 factorial goes off with this because I'm dividing both sides. N minus 10 will also go off with this. N factorial will also go off with this. So I'm left with n plus 1, n plus 1. So 10 factorial, I can reduce 12 factorial to be 12, 11, and then 10 factorial. So that this 10 factorial will also go off. I'm going to be left with n plus 1 is equal to 12 times 11. Times the 33 here. The 33 is also part here. So I'm going to have what is left is n plus 1 squared is equal to 12 times 11 times 3, 33. I can use this to be 12, 11, 3, 11. So 12, 3 is 36, 36 squared, and then 11 squared. And that's n plus 1 all squared. So if I square root both sides, I'm going to have n plus 1 to be equal to square root of this, and that's 6 times 11, 66. So n is equal to 66 minus 1, and that will make my n be 65. Number 6. The problem of a sphere is increasing at the constant rate of 2 pi. That's a volume with respect to time to define the t. We can say define the t is 2 pi. Then the rate of change of the surface area, volume is 36, so the volume is 36 pi. Find the rate of change of the surface area. That's the surface area with respect to T is what you are finding. Now, we can combine many things to have that. We can have the S div times div dt. So what's the S div? The S div can also give us ds dr times dr div. So what's the SDR? Surface area with respect to radius. So surface area of a sphere is 4 pi r square. So if you do the SDR, we are going to have 8 pi r. What's the volume? Let's work out the volume. The volume is also 4/3 pi r cube, and that's going to give us the result of 36 pi. So pi goes off, so we are going to have 4/3 r cube. Multiply both sides by 3 on 4. So that's 3 on 4 times 36, and that's r cubed. So r is cube roots of that. So 4 here, 1, 4 here, 9, 9, 3, 27. So cube roots of 27 is 3. So r is 3. So if I have 8 pi r, so that's 24 pi. 8 times 3 is 24 pi as the S, the R. The R div is the reverse of div the R. So if you do div the R here, you're going to get 3 stepping down. So that's 4 pi r squared. And r is 3. 3 squared is 9. And that's 36. 36 pi. So let's proceed. The S div, and this is the reverse, the R div. So that's the reverse of this. So let's proceed. The S div should be the SDR, which we had 24 pi, times the R div. That's 1 over 36 pi. So pi goes off. 12 here 2, 12 here 3. So the S div is 2 out of 3. Now what's div dt? Div dt is in the question as 2 pi. So we are going to have the S dt as we are finding as the S div, that's 2/3, times div dt, which is 2 pi in the question. So that's going to be 4 out of 3 pi. And that is the S div. So that's cm squared x minus 1. That's the unit.